Hello everyone. Let's discuss how to write salt scheme in practical exam. First I am taking ammonium sulfate here. First step, to write a color, we take white colored salt. So it means all the colored salts are absent. Then the second step, smell. As we are having ammonium sulfate, so ammonical smell is there. It means ammonium may be. We don't write here ammonium is confirmed. We simply write ammonium may be present. Then the third step, test for acidic radical. Here we first perform dilute sulfuric acid. What we do here, we take a salt in a test tube, add a few drops of water to it, and then 1 to 2 drop of dilute sulfuric acid. No gas evolved, so all the radicals which show test with dilute sulfuric acid like carbonate, sulfide, nitrite, they are absent. Concentrated sulfuric acid test, then we write salt plus water plus concentrated sulfuric acid. No gas formed here. So all the radicals which gives test with a concentrated sulfuric acid like chloride, bromide, nitrate, all of these are absent here. So we go for next step is test for independent radical, which is sulfate. So salt plus water, we make a salt water extract here, and then to the water extract we add barium chloride. White precipitates are formed. This shows the presence of sulfate radical in a given salt. Next step is to test for basic radical. We start with a zero group, ammonium ions. So to the salt, we add NaOH, white fumes, which get intensified when the road dipped in dilute hydrochloric acid comes in contact with a test tube, which is having a salt and NaOH solution. Ammonium may be present because dense white fumes are formed because of a ammonium chloride here. Then a confirmatory test for ammonium we perform. Salt plus Nessler reagent, brown precipitate, ammonium, confirmed. Now, next step is to write result. We write the salt, ammonium sulfate, then we mention acidic radical here, sulfate, basic radical, ammonium, precautions. You can write any two precautions. Do not taste the chemical, do not overheat, handle the chemicals carefully. Any of the precautions you can write. Similarly, you can write for lead nitrate, lead acetate, aluminium sulfate, zinc carbonate. So let's discuss how to write for zinc carbonate here. First step, color, white, so all the color salts absent. Second step, smell, no characteristic smell. So all the radicals like acetate, ammonium, they are absent here. Then the third step, test for acidic radical. In this case, first we do dilute sulfuric acid test. Salt plus water, this result in the formation of water extract. To this we add dilute sulfuric acid. Brisk effervescence comes out because of the evolution of carbon dioxide, which turns lime water milky. This shows the carbonate ion presence in a given salt. Now we go to for a confirmatory test for a carbonate. So we take a salt, then to it we add dilute hydrochloric acid, magnesium sulfate, white precipitate form, which confirm the presence of carbonate radical in a given salt. Now the next step, test for basic radical. For this we prepare original solution. We always take water soluble salt. So first step, detection for the group 0. To the original solution we add Nessler reagent, no brown precipitate, ammonium absent here. Then we go for group 1. To the original solution we add dilute hydrochloric acid, which is a group reagent for group 1. No white precipitate, group 1 absent. Then next step for group 2. To the filtrate of group 1 we pass H2S gas. You can make H2S gas with the help of mixing Na2S and dilute HCl here. no black precipitate, so group 2 are also absent here. Group 3, to the filtrate of group 2, we add ammonium chloride and add ammonium hydroxide till ammonical smell comes out. No white precipitate again in this case, so group 3 is also absent here. Then we go to next part, group 4. To the filtrate of group 3, we pass H2S gas dull white precipitate form, which shows the presence of group 4 radical, and in group 4 we have zinc because the salt of zinc are white. So to this white precipitate, to this dull white precipitate, we add potassium ferrocyanide solution. Bluish white precipitate are formed which confirm the presence of zinc. So the resulting salt is zinc carbonate. Acidic radical here is a carbonate. Basic radical is zinc. Precautions, again you write 2 precautions at the end of your experiment. Do not taste the chemical, handle the chemicals carefully. In a similar manner, you can write for the zinc sulfate. So let's talk about barium chloride. Barium, which is a group 5 radical. So the first step is a color. All salts we do in our board practical, they are white in color. So it means all the colored radicals are absent. Smell, no characteristic smell. So acetate, ammonium are absent here. Third step, test for acidic radical. First we do dilute sulfuric acid to the water extract. Water extract is salt with water. To this we add dilute sulfuric acid. As no gas is evolved, no characteristic changes there. So carbonate, sulfide, nitrite radicals are absent here. Then the next step is concentrated sulfuric acid test. To the water extract, we add few drops of concentrated sulfuric acid. Colorless gas with dense white fumes with ammonia solution, which shows the formation of ammonium chloride. The white fumes get intensified because we are having HCl. HCl combines with ammonia to form ammonium chloride. That's why these fumes, these white fumes get intensified. It shows the presence of chloride ion in a salt. Then the confirmation to chloride, we perform a silver nitrate test. To the water extract, we add dilute HNO3, then we boil, cool, and then add silver nitrate solution. White precipitate of silver chloride, which are soluble in ammonia. This confirms the presence of chloride in a given salt. Second test, you can also do chromyl chloride test here. Salt, to the salt we add potassium dichromate, which is orange in color. To this we add concentrated sulfuric acid and heat the resulting mixture. This result in the formation of orange-red vapors of chromyl chloride gas, and these vapors turns yellow when you add NaOH, acetic acid and lead acetate. Yellow solution is obtained because of the formation of lead chromate here. So this confirms the presence of chloride radical in a salt. Now test for basic radical. Next step is test to basic radical. First we make a original solution, salt with water, then test for group 0. To the original solution we add Nestle reagent, no brown precipitate form, so ammonium absent. Then we go for group 1. To the original solution dilute HCl will be added, no white precipitate form, group 1 is absent. Then to the filtrate of group 1 we pass H2S gas, no black precipitate form, so group 2 is also absent here. Next step, test for group 3. To the filtrate of group 2, we add ammonium chloride followed by ammonium hydroxide in excess till ammonical smell form. No white precipitate, group 3 absent. To the filtrate of group 4, we pass H2S gas. No dull white precipitate will be formed here, so group 4 is also absent. Now, next is a group 5. To the filtrate of group 4, we add ammonium carbonate, which is a group reagent for group 5, in presence of ammonium chloride and ammonium hydroxide, followed by acetic acid and potassium chromate. Yellow precipitate form. This shows the presence of barium radical in a given salt. Next test is a flame test. Perform flame test with the original salt. If grassy green flame is obtained, then it shows the presence of barium radical in a given salt. So the second last step, result we write. In result we write salt, which is barium chloride, acidic radical, chloride, basic radical is barium. And in last we write two precautions. Handle the chemical carefully, do not taste the chemical, or you can write do not overheat the chemicals. Let's discuss about how to write salt scheme for strontium sulfate. First step, color, white, so all the color salts are absent here. Smell, no characteristic smell, so acetate ammonium radicals are absent. Third step, that one is a test for acidic radical, where first we do dilute sulfuric acid. To water extract we add dilute sulfuric acid, no gas evolved, no characteristic changes observed, so carbonate, sulfide, nitrite are absent here. Then next step, concentrated sulfuric acid test. To the water extract, we add concentrated sulfuric acid. Again, no characteristic change. So chloride, nitrate, bromide, iodide, all these radicals are absent. Third step here is test for independent radicals. So we are testing here for sulfate radical. To the water extract, we add barium chloride, white precipitate. It shows the presence of sulfate radical in a given salt. Next step, fourth step is test for basic radical. Group 0, to the original solution we add Nestle reagent, no brown precipitate, ammonium absent. Group 1, original solution plus dilute HCl, no white precipitate, group 1 absent. Group 2, original solution plus H2S, no black precipitate, group 2 absent. To the filtrate of group 2, we add ammonium chloride with ammonium hydroxide in excess, no white precipitate, group 3 absent. Then we go for group 4. To the filtrate of group 4, we pass H2S gas, no dull white precipitate formed, so group 4, that one is also absent here. Then next is group 5. To the filtrate of group 4, we add ammonium carbonate, which is a group reagent in the presence of ammonium chloride and ammonium hydroxide. White precipitate, that one is formed here. It shows the presence of group 5, and in group 5 we have barium, strontium, calcium here. To this white precipitate, we add acetic acid, ammonium sulfate, white precipitate of strontium, that one is formed here. Flame test. To perform the flame test with the original salt, if a crimson red flame is obtained, it shows the presence of strontium in a given salt. Then the next step, result, strontium sulfate, a salt, acidic radical, sulfate, basic radical, strontium. Precaution, do not taste the chemicals, handle the chemicals carefully. Similarly, we write salt scheme for strontium bromide, for zinc chloride in a similar manner.